Structural systems in high-rise buildings. Introduction. It is difficult to distinguish the characteristics of building which categorize it as tall or high-rise building. It is difficult to make a criteria that which building is high-rise. In typical single-story area, a 5-story building will appear as tall or high-rise building. In large cities, a structure must pierce the sky, means into the clouds, around 70 to 100 stories if it is to appear tall in comparison with its immediate neighbors in the large cities. Now, introduction and definition of high-rise building defined by different bodies. Emporis standards. These standards are made from gathering the information, and according to Emporis standards, a multi-story structure between 35 to 100 meters tall or a building of unknown height from 12 to 39 floors is termed as high-rise building. That is the standards of Emporis. The International Conference on Fire Safety. Then what's the criteria for high rise? Any structure where the height can have a serious impact on evacuation. Any case of fire, then there will be serious impact on evacuation in the high rise building. So that is where the issue is very high or serious, that is the high rise. Third, Massachusetts, United States Journal Law. A high rise is being higher than 70 meter or 21 meter. Buildings higher than 100 meter is termed as skyscraper. According to Emporis, buildings 300 meter or higher is termed as super tall, and buildings 600 meter or taller is termed as mega tall. Now for this course, we have to set some guidelines. In this study, we shall consider all buildings above 35 meter are called high-rise or tall buildings. Demand for high-rise buildings. Why there is need of high-rise building construction? High-rise buildings are becoming more prominent these days due to following reasons. First, and the major issue, that is scarcity of land. There is shortage of land. In the urban areas, there is already too much development of industry, residential area, and for businesses purposes, for offices, the high rise is a very good option. Increasing demand for business and residential space. Even the residential space is very limited, so we can accommodate hundreds of people, even thousands of people in high-rise building. So that is also the demand of high-rise building. Economic growth. So that is the also now a symbol that any city who has good rate of economic growth, it has many more high-rise buildings, depending upon their businesses, offices, criteria, etc. Technological advancements. That is again the very important parameter regarding structural system. Before 1930s, there is very less advancement in the high-rise building, the calculations type system or the machinery, etc. There is very less advancement. So at that time there was difficulty, but today's that is too much easy. So that is the technology demand. So for the high-rise building. Fourth one, innovations in structural system. Again, Dr. Fazlur Rahman, I will also show in the next slides, that introduce new systems in the structural system to make the structures to the high rise. The Dr. Fazlur Rahman is also called Einstein of structural engineering. Desired for aesthetics in urban areas. In the urban areas, the aesthetics means people try to go for businesses, for their work, definitely go to city areas or the urban areas. So the aesthetics of the cities are much more beautiful with the high rise. Cultural significance and prestige. This example you can take from UAE, where Burj Al Arab and Burj Al Khalifa is present. Okay, that is the symbol. Now it's the cultural trend, which signifies the high-rise demand, and it also attracts the travelers towards their city, and they can get the more income from that tourism. That is the cultural. Human aspiration to build higher. Humans from the history always love the hills, high rise. So to achieve that heights, humans have aspiration to build higher and higher of high rise buildings. Dr. Fazlur Rahman Khan, structural engineer, he has been called the Einstein of structural engineering. Whenever you open on any book on high-rise building, you will definitely get the name of Dr. Fazlur Rahman Khan, structural engineer, and the greatest structural engineer of 20th century for his innovative use of structural system that remain fundamental to modern skyscraper design and construction. Innovations: tube structural system, frame tube, truss tube and X bracing, bundle tube, tube in tube, outrigger and belt truss, concrete tube structures and shear wall frame interaction system. These are the innovations of Dr. Fazlur Rahman Khan, structural engineer. Development of structural system. First generation of buildings 1780s to 1850. The exterior walls of these buildings consisted of stone or brick, although sometimes cast iron was added for decorative purposes. Here is a home insurance building of the first generation building in the United States. The columns were constructed of cast iron, often unprotected steel, and wrought iron was used for the beams, and the floors were made of wood. That is the first generation high-rise buildings. Second generation 1850s to 1940s, the second generation of tall buildings, which includes Metropolitan Life Building 1909, the Woolworth Building 1913, and the Empire State Building 1931. Here is the Empire State Building, are frame structures in which a skeleton of welded or riveted steel columns and beams, often encased in concrete, means often steel columns are embedded in concrete, runs through the entire building. That is the second generation buildings. Third generation buildings 1940s to present. Up till now, buildings constructed from after World War II until today make up the most recent generation of high-rise buildings. Within this generation, there are those of steel frame construction, that is core construction and tube construction, reinforced concrete construction, shear wall construction, and steel frame reinforced concrete construction. That in third generation, these type of structures are made. Hybrid systems also evolved during this time. These systems make use more than one type of structural system in a building. Means in the third generation, not only one type of system, hybrid system is also used, which is the combination of two or more structural system. Here is structural system classification. On the one side there is frames, beams, columns, etc. Here is concrete wall, and here is a core. That is a just like lift well, or where the lifts are used from the lower story to upper floors, so that is core. Okay, most of the time we use that inner core of the structure to resist the all lateral loads, almost 95% lateral loads. So these are the basic three components. Now we can make the combination. The fourth one is the tube. Okay, what is tube? Here tube is just like the arrangement of columns or the structural system in such a way that make a tube. Okay, here you can see the columns are present outside or the perimeter of the building, and some are present in the interior. That is the tube system. Okay, now frame and tube can be combined and used with tube and frame. Similarly, wall and frame, tube and wall, tube and core and wall, tube and core. These are the structural system basic, but we can combine, like we can use frames, walls, core, all in one structure. Okay, tall buildings trend. Considering the world's 100 tallest buildings in 1990s, 80% were located in North America. Almost 90% were exclusively office use. More than half were constructed of steel. In 2013, for the world 100 tallest buildings, the largest share, 43%, are now in Asia. Only one new 200-meter plus buildings was built in North America in 2013 compared to 54 in Asia. Less than 50% are exclusively office use. Almost a quarter are mixed use, and 14% are residential of tallest buildings. Almost half were constructed of reinforced concrete and only 14% are of steel. The remaining are composite or mixed structural materials, means composite where the steel sections are embedded in concrete, that are composite members, and mixed structural material means different type of structural materials are used in the construction of high-rise buildings. Tall building trends. On the horizontal axis of this chart, there is a time 1930, 1940 up till 2013, and on the y-axis there is number of buildings. Okay, that is 100 tallest buildings by structural materials, steel, concrete, composite, mixed, and unknown. Okay, in history. In 1930s, the more or almost 90 to, you can say, 100% is of use of steel. Then after 1970s, the new material concrete, the trend of concrete material starts. Okay, you can see in 2013 up till 50% space is taken by concrete, and you can say up to 35 to 40% by composite, and only 14% by steel. What is composite? Okay, here you can see that is a concrete beam. The steel section is embedded in the concrete. Similarly, the concrete composite column, where the steel section embedded in the column. A composite tall building utilizes a combination of both steel and concrete acting compositely in the main structural system. By using in the composite form, the strength of beam or strength of column increases too much. A mixed structure, tall building is any building that utilizes distinct steel or concrete systems above or below each other. That is a mixed, where we use different type of materials. Structural concerns, where means the loading type, the behavior of structure. The primary structural skeleton of tall building can be visualized as a vertical cantilever beam with its base fixed in the ground. Okay, first of all, what is cantilever beam? Here there is one side on the beam, there is a fixed support and the other side is left free. That is a cantilevered beam. Okay, here you can see here is a tall building. The tall building, one end is fixed in the ground and other end is free in the air. So that's why the tall building can be visualized as a vertical cantilever beam with its base fixed in the ground. The structure has to carry the vertical gravity loads and lateral wind and earthquake loads. Means this high-rise building should have the capacity to resist the vertical loads. Vertical loads in the cell weight of the members, partition load, human loads, all types of vertical loads. And second, in the lateral loads there are two: wind and earthquake. In wind and earthquake are the lateral loads which strike horizontally to the building. Okay, here the nomenclature of different type of loads are shown: snow load, dead load, live load, wind load, impact, and even sometimes blast load. When the wind loads strike to the building in the lateral, but when the wind loads blows, the columns in the windy side where the wind stretches apart, means they go in the tension sense, and on the other side of the building goes into the compression sense. Okay, just like when we apply the load from the top, the bottom side goes into compression and top side goes into tension, and the columns on the other side squeezes together, means goes into compression. Fighting gravity. The weight of the building is supported by group of vertical columns. Each floor is supported by horizontal steel or concrete girders running between vertical columns. Mean vertical columns, steel or concrete beams are running. Okay, either the vertical members may be of steel or concrete. Curtain wall made of steel and concrete attaches to the outsides, means curtain walls which cover the building. Okay, so these walls are also either steel and concrete. Wind resistance. Building taller than 10 story would generally require additional steel for lateral system. Means in high-rise building, when there is number of stories are more than 10, then there will be more requirement of additional steel due to lateral loads of wind. In the structure concern, that is also wind turbine buildings testing in the wind turbines. For taller skyscrapers, engineers have to construct especially strong cores through the center of building for wind resistance. Okay, here are the models. Okay, that are present in the wind tunnels. Different structures are also modeled. Then we see the behavior of the structure. Here again the buildings are modeled and studied in the high wind speed, and the behavior of the buildings are studied, means in how much manner or how the way the buildings is going to fail, that we can test in the wind turbines. As the building becomes taller and buildings sway due to lateral forces becomes critical, there is a greater demand on the girder and the columns that make up the rigid frame system to carry lateral loads. Means when the buildings go higher and higher, then there come a duty on the girders and columns to resist the lateral loads. Classification of tall building. Structural system. In terms of structural system, can be classified based on structural material used, such as concrete or steel. Structural systems of tall buildings can also be divided into two broad categories, that are interior structures and second one, that is exterior structures. This classification is based on the distribution of components primary lateral load resisting system over the buildings. Means columns are present on the outer side or the inner side, or concrete walls are present on the inner side or the outer side. This classification is based on that. okay, where the load resisting elements are present. A system is categorized as an interior structure when the major part of lateral load resisting system is located within the interior of the buildings. Okay, means the major load resisting element are present at the interior of the structure. Similarly, likewise, if the major part of lateral load resisting system is located at the building perimeter, a system is categorized as an exterior structure. It should be noted, however, that any interior structure is likely to have some minor components of the lateral load resisting system at the building parameter. Means these systems, for example, if one system is the interior system but it has some slight components also on the perimeter, it doesn't mean the one have purely of interior, one is purely of exterior. Okay, it can be mixed up, and any exterior structure may have some minor components within the interior of the building. Here, interior structures. By clustering steel / concrete columns or even concrete walls, okay, or you can say lift wells and beams in the core, engineer can create a stiff backbone that can resist tremendous wind forces. Okay, you can see the major part of structural system is the center of the building. The inner core is used in an elevator shaft, and the design allows lots of open spaces on each floor. Okay, you can see that is the interior structures. Now, exterior structures. In newer skyscrapers like the Cirrus Tower in Chicago, engineers move the columns and beams from the core to the perimeter, creating a hollow, rigid tube as strong as the core design but weighing much less. That is the second technique of structural system, that is exterior structures. Now, first of all, interior structure system types. First one, that is a basic type, rigid frame beam column system. A rigid frame in structural engineering is the load resisting skeleton constructed with straight or curved members interconnected by mostly rigid connections which resist movements induced at joints of members. Its member can take bending moment, shear and axial. Can build up to 20 to 25 floors. That is the basic type that is most commonly used in the high-rise construction, where the tall building, high-rise or tall buildings are constructed. This is the basic combination of beams and columns. That is the rigid frame. Second of interior, that is shear wall structure. Concrete continuous vertical walls from the bottom to the top. Here, in the center of the building, concrete walls may serve both architectural partitions and structurally to carry the gravity and lateral loading. This can serve two purposes. Okay, one, for the architecture, you can place the glass on one side for the static purpose of on the lift well or the lift walls, and second, these concrete walls can take the major part of the load by itself. Very high in plane stiffness means rigidity, and means these concrete walls are very stiff, and strength make them ideally suited for bracing tall buildings. Okay, this is also suitable for bracing tall buildings. Usually built as the core of the building, these act as the core or the backbone of the building. Can build up to 35 floors with the shear wall structures. Why shear wall named? When the horizontal forces strike to the building, then the horizontal or the lateral loads are act as a shear force. So that's why that these walls are shear wall structures. Outrigger structures, that is again the type of interior structures. The core may be centrally located with the outriggers. Okay, what is outrigger? I will show. The core, the central part, that is the core of the structure, located with outriggers extending on both sides. Okay, you can see on the perimeter there is trusses elements, or in some cases it may be located on one side of the building with outriggers extending to the building columns on the other side. Okay, here is a more good demonstration. The outriggers are generally in the form of trusses. You can see at a number of floors, okay, for example at 30 floors or even again at after 30 floors, there is a horizontal belt is provided, belt trusses as vertical virtual outriggers. Even these trusses can go between 1 to 2 stories, can take up to 1 to 2 stories. In steel structures or walls in concrete structures that effectively act as stiff headers, including a tension compression couple in the outer columns. Okay. Belt trusses are often provided to distribute these tensile and compressive forces to a large number of exterior frame columns. Means these belt trusses are provided to act as a tension and compression element and to transfer these forces to the outer elements of frame. Okay, here is a plan view. That is a brace core shear wall at the center. Okay, at the outside belt trusses are provided, and the main resisting element, that is the inner core. Here is the number of stories and the type of structure. Braced hinge frames, okay, up to 10. Rigid frames of concrete, that is can go up to 20 stories. Rigid frames of steel, you can go for 30 stories. Concrete shear wall plus steel hinge frames may 33, 34, and braced rigid frames can go up to 40. Concrete shear wall and steel rigid frame can go up to 60. If we can combine with concrete shear wall and concrete frame, we can go easily up to 70 stories. And with the outriggers option, okay, when we provided the belt trusses or the concrete walls after certain heights throughout the story of the building, then we can go up to 150 stories. Okay, that is very much good benefit of the outrigger type of structure. The second type of structural system, overall structural system, that was exterior structures. The first one is the tube system. The tube system concept is based on the idea that a building can be designed to resist lateral loads by designing it as hollow cantilever perpendicular to the ground. Okay, means this type of structure maybe from the center is hollow. In the simplest of tube, the perimeter of exterior consists of closely spaced columns that are tied together with deep spandrel beams through moment connections. Or let's take, here is an example of frame tube. In this high-rise building, the columns are closely spaced at the outside and the interior space is left empty. Okay, that is the type of tube system. Here, perforated shell tube means in the concrete walls holes are left. Okay, the concrete walls are present on the perimeter of the high-rise building. Deep spandrel beam with less opening. Truss tube, okay, all the columns are present at the perimeter, but these are also diagonally braced. Okay, that is truss tube. Bundle tube. Now columns are made in such a way that there are number of tubes within the tube. Exterior tube, then within interior tubes, so that is bundle tube. Frame tube in tube. At the exterior number of columns and at the interior some other arrangements of columns or maybe concrete wall, then this type of structure is tube in tube. Perforated tube in tube, okay, just introduce a tube also at the inside. All the types are same. This assembly of columns and beams form a rigid frame that amounts to a dense and strong structural wall along the exterior of the building. Okay, that benefits the stiffness and rigidity on the exterior of the building and act as a hollow. The different tubular system are frame tube, brace tube, bundle tube, tube in tube. Okay, that truss tube is the also the brace tube. All types are discussed already. The second type of exterior system, that is Diagrid system. With their structural efficiency as varied version of the tubular system, Diagrid structures have been emerging as new aesthetic trend for tall buildings in the era of mixture of different styles. Okay, here you can see a grid is formed on the exterior of the exterior perimeter of the structure. Okay, this also giving the aesthetic sense very good, and this is the type of Diagrid. Early design of tall buildings recognized the effectiveness of diagonal bracing members in the resisting lateral forces. These diagonal members give the good aesthetic as well as structural sense, but the difficult part of this type of construction is is of the joints. Their joints should be made with the proper structural sense, okay, with the movement connection, all types of these, that is more important in this Diagrid system. Most of the structural system deployed for early tall buildings were steel frame with diagonal bracing of various configurations such as X, that is X, or sometimes with K and children. However, while this structural importance of diagonals was well recognized, that is X, the aesthetic potential of them were not appreciated since they were considered obstructive for viewing the outdoors. Their aesthetic may disturb the viewers from the inside to see outside due to the hindrance of diagonal bracing. That is the bad impact on the aesthetics from the inside. Outside it's look good. Efficiently resist lateral shear by axial forces in the diagonal members but have complicated joints. Third one, that is space truss. Okay, the truss which is in the 3D plane, that is a space truss. Space truss structures are modified brace tubes with diagonal connecting the exterior to interior. Means you can see here, just like the truss elements, this part is connected to the other side with the interior elements. So you can say this is the advanced form of tube system. All diagonals in a typical brace tube structures, all the diagonals which connect the core members, vertical corner columns in journal, are located on the plane parallel to the facades. Okay, the meaning of these three lines, that the we can see on the outside this is just like the truss structure. Now this joint is also connected with the on the other side, okay, that forms the 3D truss. However, in space trusses, some diagonal penetrate the interior of the building, that forms the space truss. Exoskeleton structure. In exoskeleton structure, lateral load resisting systems are placed outside the building lines away from the facades. Now the facade may be of glass system that is present on the inside, and all the structural system are present on the outside, means the away from the facade. Due to the system compositional characteristics, it acts as primarily building identifier, one of the major roles of building facades in general cases. Fireproofing of system is not a serious issue due to its location outside the building line. That is the benefit of exoskeleton structure. These type of structures can be used where there is issue of fire. That is the Hotel de las Truss, and in the Space Truss, that's the Bank of China, Hong Kong. Super frame structures. Super frame structures can create ultra high rise buildings up to 160 floors. That is a very big achievement in the super frame structures. Super frames or mega frames assume the form of portal which is provided on the exterior of the building. You can see the number of arrangements either of trusses or columns on the exterior of building. Okay, as it goes up there is setback, that is a setback, and the structure is optimized to lower width, smaller width, and as it goes to the up it is just like the pole. The frame resists all wind forces as the exterior tubular system. Okay, you can see exterior at the corners tubular system. The portal frame of the super frame is composed of vertical legs in each corner of the building, which are linked by horizontal elements at every 12 to 14 stories. Okay, here you can see 12 to 14 stories. These are linked with the horizontal members, either with truss or concrete walls. Since the vertical elements are concentrated in the corner areas of the building, maximum efficiency is achieved or is obtained for resisting wind forces. Now the high-rise building case study. Case study of PETRONAS Tower in Malaysia. PETRONAS Tower is a symbol of national pride and shows the nation's achievement in the world economy and technologies. Concrete was used for its construction mainly because it was easily available and cheap when compared with steel, which was a new material for the builders. That is a concrete at the time of construction of Petronas Tower. The architect successfully incorporated Malaysian and Islamic motifs in the design. The sky bridge was an important feature of the design, which was implemented later. First, these towers are made, then the connecting bridge are made later. That is sky bridge. Petronas Tower has tube-in-tube structural system. The structural members are made with high strength concrete which was cast inside, means construction is concrete made on the side and casted on the side. The perimeter columns are held together with the help of ring beams. The ring beams are the circular outer beams. The internal core structure is made of concrete shear walls. The building didn't require extra damping system because the heavy structural members made of concrete, even though no new advancement in technology was made during this project. Okay, all the available material and technology is used that is going in the trend. The available technology was used smartly. Whatever technology available, that used smartly. Now here, that is the Petronas Tower, height above the ground that is 542 meter, and in the ground that is 105, or you can by adding 20 meter, that is roughly 20 meter. Then the pile foundation is used in the Petronas Tower. Burj Al Khalifa, Dubai, UAE. Okay, here the new structural system is used that is never used before. The Burj Dubai project is designed to be centerpiece of large-scale Burj Dubai development that rises into the sky to an unprecedented height of 800 meters, and that consists of more than 160 floors. The decision to build Burj Khalifa is reported based on the governor's decision to diversify from an oil-based economy to one that is service and tourism based. Unlike many super high-rise buildings with deep floor plates, means The governor decision that the oil is going to obliterate in this country. So that's why the governor decision to make the tourism impact on his country, so make large buildings. The Y-shaped floor plans of Burj Dubai maximize views and provide tenants with plenty of natural lights. I will show in the next slide the plan view that is Y-shaped. According to officials, it is necessary for projects like Burj Khalifa to be built in the city to garner more international recognition and hence investment. The structural system for Burj Khalifa was a new system developed for building. The system is called buttress core. In this system, the lateral loads and gravity loads are shared equally between the interior core and the perimeter, means interior and exterior. Both systems are combined in this technique. Structural systems linked by the link beam, which makes the structure super strong. Here is a Y shape of the Burj Khalifa. Okay, the central core is also connected with the exterior by concrete walls by the link beams. The image shows the structural system employed in the building. The blue members are the load carrying elements, okay, carrying concrete wall system. All the wall structures are linked to the core with the help of link beams. Future of tall building. Nothing could be more stunning than the latest generation of skyscrapers. People attract with that. Known as super talls. A tower has to be over 300 meters high to qualify as super tall, but there is no shortage of contenders. At 8 to 9.8 meter high, the Burj Khalifa in Dubai is undeniably the world's tallest building, but it won't be for very long as the race to build upwards continues around the world. For example, Dubai, okay, this is the largest building. What it is impacting, parting the impact on the world in the books, in the literature, in their libraries, each and every, this era will be written as the tallest building, that is Burj Khalifa. We are entering the era of megatall. The term is now officially being used by the council to describe buildings over 600 meters in height or double the height of a super tall. Okay, that is a megatall. 2 times super tall, that is a megatall. Conclusion. With the present technology and known materials, it is possible to build more, higher and faster. It is now possible to build skyscrapers so far using prefabricated beams, columns, slabs, all things are prefabricated, and with a very less time there can be built the skyscrapers. That it can lead to environmental problems, stress on resources and overcrowding if not controlled. Traffic control, multiple issues in the urban areas. So that can be countered with the prefabricated units. To build higher, the base of the building will have to be made wider. The bundle tube system was a great innovation and was able to span great heights during its time. To attain the height of Burj Khalifa, the bundle tube system will need a bigger base when compared with the buttress core system. New improved structural systems and new materials in the future can lead us to even greater heights and more stable buildings. It's not technology holding building back, okay, high rise. It's the money. Thank you. That's all for high rise building, the structural system in high rise building. Have a nice day.